Here we have the second example of solving a single cube root equation. Let's read this together. It's cube root of 27x cubed minus 5, all of that minus 3x equals 2. Again, this is a single cube root equation because it only contains one cube root expression in it. We're going to follow the same steps we did for example 1. We're going to move all the non-cube root expressions to one side. Again, I would recommend moving those to the right and keeping the cube root on the left, but it doesn't really matter. That's just for convention's sake. So in this case, I'm going to add 3x to both sides. Now I have 2 plus 3x on the right. Now, typically what we'll do is put the x term first, so we're going to switch those and have 3x plus 2 on the right, and keep our cube root of 27x cubed minus 5 on the left. And again, that's step 1 of moving that non-cube root expression away to the other side. Then move the radical expression to the other side. Now typically if you do one thing, then it's already isolated. So basically we're just separating the cube root term from anything that's not. Step 3 is to cube both sides. That's why we isolate them, because when we do cube both sides, it will cancel that cube root. And now on the left, we're just left with 27x cubed minus 5. On the right, when we cube this expression, and just forgive me for a second, it looks like this was cut off, so let me see if I can show you the rest of this. Okay, so what I actually had to do is rework this out so you guys could see this. So anyways, just remember, when you cube something, you cannot distribute this exponent to the 3x and the 2. That's not how it works. That's not fundamentally sound. What you can do is multiply 3x plus 2 times itself 3 times, because that's what it means when you cube something. What I did was I FOILed the first two binomials. So it'd be 3x times 3x equals 9x squared. 3x times 2 is 6x. 2 times 3x is 6x. Add that up to get 12x, and then 2 times 2 is 4. Always check your work. If you're not going to show as much work, double check it before you move on. And then we're multiplying that obviously by the last 3x plus 2. Then what I did was I distributed the 3x into each of these terms. 3x times 9x squared is 27x cubed. 3x times 12x is 36x squared. And 3x times 4 is 12x. See how I'm checking everything as I'm doing it? If you don't show all your steps, please double check before you move on. And the reason I'm doing this is because we ran out of room, and so I got to try to fit everything on this page. 2 times 9x squared. So now we have to distribute the 2 to this trinomial. 2 times 9x squared is 18x squared. I'm going to put it under the 36x squared. 2 times 12x is 24x. 2 times 4 is 8. Then just add them up. 27x cubed adds to itself. 36 plus 18 is 44 and 54x squared. 12x plus 24x is 36x. And then we have the 8. So now we have this equation. 27x cubed minus 5 equals 27x cubed plus 54x squared plus 36x plus 8. So now what will happen is these 27x cubes are going to cancel. Pretty nifty, because we have one on the left, one on the right. Now we have negative 5 equals 54x squared plus 36x plus 8. When you have a quadratic equation, you want to get everything on one side, so I'm going to add 5 to both sides, and now we have 0 equals 54x squared plus 36x plus 13. Now we have a quadratic where a is equal to 54, b is equal to 36, and c is equal to 13. Now, as I've taught you guys before in the past when solving quadratic equations, figure out what b squared minus 4ac is. That's called the determinant. If the determinant is negative, we will have no solution. And in this case, when we work the math out, indeed, the determinant will be negative. Because 1296 minus 2808 is a negative number, I don't even have to figure out what that number is. Since the determinant is negative, I know that it will be no solution. So for our example 2, it's okay. That's our answer. There will be no solution. There is no x value that will make this equation true. That's it for this example. If you have any other questions about it,